This video, we'll be discussing the evolution of computing, more specifically, the evolution of the technologies that have brought upon the modern computing era. The purpose of this video is so we can appreciate how fast technology is evolving and the people who have brought us to this point. Many inventions have taken several centuries to develop into their modern forms, and modern inventions are rarely the product of a single inventor's efforts. The computer is no different. The bits and pieces of the computer, both hardware and software, have come together over many centuries, with many people and groups each adding a small contribution. We start as early as 3000 BC with the Chinese abacus. How is it related to computing, you ask? The abacus was one of the first machines human had ever created to be used for counting and calculating. Fast forward to 1642, and the abacus evolves into the first mechanical adding machine built by mathematician and scientist Blaise Pascal. This first mechanical calculator, the Pascaline, is also where we see the first signs of technophobia emerging, with mathematicians fearing the loss of their jobs due to progress.
Also in the 16th, from the 1660s to the early 70s, we meet Gottfried Leibniz, a pioneer in many fields, most doubly known for his contributions to mathematics and considered by many the first computer scientist. Inspired by Pascal, he created his own calculating machine, able to perform all four arithmetic operations. He was also the first to lay down the concepts of binary arithmetic, how all technology nowadays communicates, and even envision a machine that used binary arithmetic. From birth, we're taught how to do arithmetic in base 10, and for most people, that's all they're concerned with, the numbers 0 to 9.
Back on topic, progressing to the 18th, we meet the Charles Babbage. Babbage is known as the father of the computer with the design of his mechanical calculating engines. In 1820, Babbage noticed that many computations consisted of operations that were regularly repeated, and theorized that these operations could be done automatically. This led to his first design, the difference engine. It would have a fixed instruction set, be fully automatic through the use of steam power, and print its results in the table. In 1830, Babbage stopped work on his difference engine to pursue his second idea, the analytical engine. Elaborating on the difference engine, this machine will be able to execute operations in non-numerical orders through the addition of conditional controls, store memory, and instructions from punch cards essentiality, making it a programmable mechanical computer. Unfortunately, due to lack of funding, his design never came to reality, but if they would have sped up the invention of the computer by nearly 100 years.
In 1936, Alan Turing proposed the concept of a universal machine, later to be dubbed the Turing machine, capable of computing anything that is computable. To this point, machines were only able to do certain tasks that the hardware was designed for. The concept of the modern computer is largely based off Turing's ideas.
Vacuum tube era marks the beginning of modern computing, the first technology that was fully digital, and unlike the relays used in previous computers, were less power-hungry, faster, and more reliable. Beginning in 1937 and completing in 1942, the first digital computer was built by John Atanasoff and his graduate student Clifford Berry. The computer was dubbed the ABC. Unlike previously built computers like those built by Zeus, the ABC was purely digital. It used vacuum tubes and included binary, math, and Boolean logic to solve up to 29 equations at a time. In 1943, the Colossus was built in collaboration with Alan Turing to assist in breaking German crypto codes. Not to be confused with Turing's Bombay that actually solved Enigma, this computer was fully digital as well, but unlike the ABC, was fully programmable, making it the first fully programmable digital computer. Completing construction in 1946, the Electrical Numerical Integrator and Computer, aka the ENIAC, was completed, composed by nearly 18,000 vacuum tubes and large enough to fill an entire room. The ENIAC is considered the first successful high-speed electronic digital computer. It was somewhat programmable, but like Aiken's Mark I was a pain to revive every time. The instruction set had to be changed. The ENIAC essentially took the concepts from Atanasov ABC and elaborated on them in a much larger scale. Meanwhile, the ENIAC was under construction. At this point, you can see that computing had officially evolved into its own field from mechanical to electromechanical. Relax that took milliseconds to digital vacuum tubes that took only microseconds from binary as a way to encode information and punch cards to being used with Boolean logic and represented by physical technologies like relays and vacuum tubes to finally being used to
It contains essentially those things which the modern computer has in it, although in somewhat primitive form. This machine has stored program concept as its major feature, and that in fact is the thing which makes the modern computer revolution possible.
store instructions and programs from the abacus as a way to count Pascal's mechanical calculator, the theories of Leibniz, Alan Turing, the visions of Babbage.
Transistor era. Vacuum tubes were a huge improvement over relays, but still they didn't make economic sense in a large scale. For example, of the ENIAC 18,000 tubes, roughly 50 will burn out per day and around the clock of team technicians will be needed to replace them. Vacuum tubes were also the reason why computers took up the space of entire rooms, weighed multiple tons, and consumed enough energy to power a small town in 1947. The first silicon transistor was invented at Bell Labs, and by 1954, the first transitionized digital computer was invented, aka the TRADIC. It was composed of 800 transistors, took the space of 0.085 cubic meters. Compared to the 28, the ENIAC took 100 watts of power and could perform 1 million operations per second. Also, during this era, we begin to see major introductions on both the hardware and software aspects of communicating. On the hardware side, the first memory device, the Random Access Magnetic Core Store, was introduced in 1951 by J. Forrester. What is now known as RAM today. The first hard drive was introduced by IBM in 1957. It weighed 1 ton and could store 5 megabytes, costing approximately $27,000 per month in today's money. On the software side is where a lot of major innovation and breakthrough began to come. This because computer hardware and architecture was beginning to become more standardized instead of everyone working on different variations of a computing machine. Assembly was the first programming language to be introduced in 1949, but really started taking off in this area of computing. Assembly was a way to communicate with the machine in pseudo English. Instead of machine language, aka binary, the first true widely used programming language was Fortran, invented by John Backus at IBM in 1954. Assembly is a low-level language and Fortran is a high-level language. In a low-level language, while you aren't writing instructions in machine code, a very deep understanding of computed architecture and instruction is still required to execute a desired program, which means a limited number of people have the skills and it is very error-prone.
This era marks the beginnings of the modern computing era, and where the exponential trend of computing performance really began. While transistors were a major improvement over vacuum tubes, these still had to be individually soldered together.
As a result, the more complex computers became, led to more complicated and numerous connections between transistors, increasing the likelihood of faulty wiring. In 1958, this all changed with Jack Kilby of Texas Instruments and his invention of the integrated circuit. The integrated circuit was a way to pack many transistors into a single chip instead of individually wiring transistors. Packing all the transistors also significantly reduced the power and heat consumption of computers once again and made them significantly more economically feasible to design and buy. Integrated circuits sparked a hardware revolution and beyond computers assisted in the development of various other electronic devices due to miniaturizations such as the mouse invented by Douglas Engelbart in 1964. He also demonstrated the first graphical user interface. As a side note, computer speed, performance, memory, and storage also began to iteratively increase as ICs could pack more transistors into smaller surface areas.
People blink less when they use computers, while the average person blinks about 20 times a minute under a normal circumstances, while people on computers only blinks about 7 times a minute. A common reason you may blink less is due to computer vision syndrome. This can happen when you use computer for a long time without taking a break. To prevent this issue, you should learn how to control yourself using a computer to avoid health problems. Do you even know that the first computer mouse was made out of wood and it was invented by Douglas Engelbart by 1964? The first mouse was carved made out of wood and had just one button. He was trying to figure out the better ways for computer users to interact with computer.